Now, there's only 4 different types of fog that you need to remember. So please study these. There's a few questions on the test about fog. Fog is always a confusing thing for students. Just go over these slides and try to understand how it works. The name of them is not always obvious. So what you need to find is a way to memorize what the name is for each of these phenomenon. But all 4 of the scenarios I just showed you are what's going to create fog. We have an air mass that needs to be cooled off to the dew point temperature, and when it is, and we have visible moisture, we have fog. So fog is nothing more than a cloud located on the surface. And that's going to happen when an air mass that's close to the ground is going to be cooled off to the dew point. And a different method, we've just seen them. And it's going to be classified in the manner in which it forms. The first one is going to be called radiation fog, and I'm going to get to that in a minute. The second one is called advection fog, upslope fog, and then the last one is called steam fog. Let's take a look at each of them individually and how they get formed. Radiation fog happens just like this, and it's going to be usually in an area that's got mountains around it because it's going to keep that air mass from moving anywhere. So what happens is that with radiation fog, we have an air mass here that's kind of trapped in a valley. And as it's trapped in the valley, what happens is as the ground cools off, it's going to cool off that air mass as well. And as it does, then that air mass becomes saturated. That's radiation fog. That's going to happen in the valley, and you'll see it. You don't need a whole lot of wind for this to happen. You just need basically a low-lying area between mountains and to trap that air mass. And as the ground is going to cool off rapidly, then it's basically going to force that air mass that's trapped in there to cool off to the dew point, in which case you have fog that shows up. Now, if the sun rises, then it's going to burn through it very quickly because it's all of a sudden going to basically just heat up that air mass and not be saturated anymore. So that's how you get rid of radiation fog. And in some cases, when it's really, really cold outside, that radiation fog is going to turn into ice fog, which is not a good thing. It's just basically ice suspending in the air. And if you drive through this or fly through this with your drone, then you can get in pretty big trouble. This is an example right here. You can see the little valley, and then you can see how the fog is just formed right inside of the valley. And it creates like pockets kind of fog. It's not really thick, spread out fog. It's just pockets. The next one is called advection fog, and I want you to think about this one as the San Francisco fog, if you want. What we have is we have an air mass that's moist because it's coming from over the ocean or over the sea, and we have a sea breeze that's moving that air mass over a cold surface, over the ground. Remember the sea breeze? As the sea breeze pushes the warm air mass over the cold surface, that cold surface is going to cool off the air mass and then make it saturated. We're cooling down a moist air mass into the dew point, at what point we have fog. In this case, what we need for this is we need wind. We need wind to move the air mass from the water all the way to the surface. And at one point, we have a warm, moist air mass moved over a cold surface. And obviously, that's going to be found in coastal areas when you have some kind of sea breeze. One thing that you'll see in the test is there's a question that says, in the winter, if you have an air mass that moves inland from the coast, then what kind of fog is being created? Well, this is the typical San Francisco scenario where you have just something moving and then becoming advection fog. And here's a picture right here of advection fog, or this one right here is also another picture.